Okay, in this first objective, we looked at some review concepts related to trigonometric functions. So up at the top here, you'll see just a reminder of what Pythagorean Theorem states. You've got some Pythagorean triples, some common ones there that are going to be handy for you to know. Although, obviously, if you don't know these, you can always find your missing sides using Pythagorean Theorem. And then your sine, cosine, tangent, cosecant, secant, and cotangent relationships there, which some people memorize these using phrase like so katoa or cho sha cow, or something along those lines. So we're going to look here first, numbers 1 and 2, finding the 6 trigonometric ratios, all stated above, for angle A in each of the following triangles. As we work through this little review lesson here, you'll notice there are kind of 2 of each. 1 is so that I can model it, kind of remind ourselves of what we did. Number 2, so that you can try it on your own. And so I'm going to encourage you to do that as you watch the video. If you already remember how to do this, then feel free to pause it, do both of them on your own, and then just check your answer when you're ready. You don't have to listen to the whole explanation if that wouldn't be helpful. But if you look at the problem and you're sitting there going, I don't know that I remember this, then maybe listen to the full explanation of number 1, but then make sure to pause the video, try that second one on your own, and then restart the video, either fast forwarding to the answer if you feel like you're just good to check your answer, or listening to the whole explanation if you feel like you still didn't quite get it. Okay, so here we go. Number 1, we're going to start by finding any missing sides using Pythagorean Theorem or our triples. This particular triangle is a 7, 24, 25 triangle. Although, again, if you did not have that Pythagorean triple memorized, you could always find that missing side by doing your a squared plus your b squared equals your unknown, your c squared. 7 squared is 49, 24 squared is 576, 49 plus 576 is 625, and so then if I square root both sides, I get that c would equal 25. And so you can find that 25 using Pythagorean Theorem if you need to. Okay? Now that we have that missing side, we can identify all 6 of our trig. So my sine of A, my cosine of A, and my tangent of A, my cosecant of A, my secant of A, and my cotangent of A. Okay, so sine of A, sine is opposite over hypotenuse. Look at this angle here, opposite would be 7, over hypotenuse would be 25. That's my sine up here. Cosine, adjacent over hypotenuse, adjacent is 24 over my hypotenuse, which is 25. And tangent, opposite over adjacent would be 7 over 24. These 3 then, you either have their ratios memorized, cho, sha, ko, hypotenuse over opposite, etc. for each of the 3, or you can remember that cosecant is the reciprocal of sine, and secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. And so if I flip each of these, 25 over 7, 25 over 24, and 24 over 7, reciprocal for each of them, you get your cosecant, secant, and cotangent. Okay? Okay, so go ahead and pause the video, give number 2 a shot, restart it when you are ready. Okay, number 2, we have a 12, 13, the missing side would be 5, so again a Pythagorean triple, or my unknown squared plus my 12 squared equals my hypotenuse squared. 12 squared is 144, 13 squared is 169. Subtracting this 140 over, we get a squared equals 25, and then square rooting both sides, a equals 5. Okay, and then so setting up each of your ratios, sine of A, here's A here, opposite over hypotenuse would be 12 over 13. Cosine of A, adjacent over hypotenuse would be 5 over 13. And then tangent, opposite over adjacent, would be 12 over 5. And then for each of your 3 terms, cosecant reciprocal, secant reciprocal, and cotangent reciprocal. Okay, so those were your trig ratios that you would have learned last year. After you learned those trig ratios, you then looked at how to use those trig ratios to solve for missing angles or missing sides. So again, you're going to see 2 of each here, so 1 for me, 1 for you to try on your own. First up, we have solving for missing sides. Okay, so if we start by identifying how the sides are related to my angle here, this side 8 is my opposite to 20. This side here is the hypotenuse of my triangle. And so then we have to determine which trig ratio is used. If we have opposite and hypotenuse for 20, it means that we are either doing sine or cosecant, whichever one you prefer. I find most people prefer sine. And so sine of my 20-degree angle there is opposite over hypotenuse, 8 over x. And with that, we can now isolate x and solve. Okay? So isolating here, if I multiply both sides by x, those will cancel. I get x times sine of 20 degrees is 8. And then dividing this sine 20 degrees over to isolate x, we get that x equals whatever 8 over the sine of 20 degrees is. If you then plug that into your calculator, 8 divided by sine of 20 is 23.390. Okay, go ahead and pause the video, give number 4 a shot on your own. Okay. Number 4, identifying what trig is at play. For this angle here, we've got our adjacent in our x and our hypotenuse in our 17. And so this would be either using cosine or secant. Most people I find prefer to use cosine. So in this case, we have cosine of my 75 degrees equals adjacent over hypotenuse, x over 17. And so then multiplying both sides by that 17, we get that x equals whatever 17 times the cosine of 75 degrees is, which if you use your calculator, plug that into your calculator, you will get it's about 4.399. Okay. Next up, numbers 5 and 6, we're going to now solve for our angle in this one. Same initial steps though, we still need to figure out what trig is at play. So we're going to start by identifying our sides, establishing our trigonometric function. For this angle, we've got our adjacent in that 4 root 23 and our hypotenuse in the 25. And so again, we're either using cosine or secant. Again, most people prefer cosine. Okay, so we have cosine of x equals my adjacent, 4 root 23, over my hypotenuse, which is 25. Okay? You would have then learned that there are inverse trig. It's what moves this cosine over to the other side. And so in this case, if we use this inverse trigonometric function here, and do cosine to the -1 of both sides. I shouldn't say to the -1, inverse cosine. If we take the inverse cosine of both sides, we end up with x equals whatever the inverse cosine of 4 root 23 over 25 is. Okay, and then again, if you pick up your calculator, plug that into your calculator will tell you that that is right around 39.885. Okay, so then go ahead and pause the video, give number 6 a shot, restart it when you are ready. Okay, and number 6, identifying our trig here, we have our opposite and our adjacent. And so for this one, our trigonometric function would be either tangent or cotangent. So tangent of x, opposite over adjacent, would be 9 over 4. To move this tangent to the other side, we need to take the inverse tangent of both sides. And so we get, when those cancel, x equals whatever the inverse tangent of 9/4 is. And then one more time, if you pick up your calculator and plug that into your calculator, you get that that is about 66.037. Okay. Okay. After that, we then reviewed your special right triangles. So we have 30, 60, 90s and 45, 45, 90s. And so we drew both of those here for you, so you have them to remember, or to remind yourself of. 45, 45, 90, just as a reminder, the hypotenuse would be 1. Your two side lengths are root 2 over 2 and root 2 over 2, or 1 over root 2 and 1 over root 2, whichever one you prefer. On the 30, 60, 90, your 1 would be your hypotenuse across from the 60-degree angle, because that's the bigger angle. You have the bigger side at root 3 over 2. And across from the 30-degree angle, you have the smaller side at 1/2. Okay? So then here we go. Number 7, we're going to use our right triangle trig and the sum of the angles in a triangle to solve for this triangle, which means finding all the angle measures. Excuse me, sorry. And the length for each side of the triangle. So in number 7 here, we have 30 and 90, which tells me that this missing side here is 60 degrees. Or I should say missing angle. This missing angle there is 60 degrees. Okay? Your missing side lengths then, because this is a 30, 60, 90, I know that this side here across from my 90 is my one side. And so I can tell that all of my sides therefore have been multiplied by 12, because it's no longer 1, right? It's become 12, so it's been multiplied by 12. And so as I find each of my other sides, I need to keep that in mind. Each of those sides has been multiplied by 12. Okay? So first up, we have across from the 30 degrees. Across from 30 degrees is 1/2, which has again been multiplied by 12. So if I were to show that, 1/2 times that 12 is 6. And so my side across from the 30 degrees, the A, the side of 6. Across from the 60 degrees is my root 3 over 2, which has also been multiplied by 12, which would give me 6 root 3. Okay, and we've got our side lengths. Okay, go ahead and pause the video and restart it when you are ready. Okay. Number 8, we are looking at two angles of 45 and 90, which means my missing angle over here would be another 45-degree angle. Remember, the three angles of a triangle all add up to 180. Okay, meaning the one side I do know is my hypotenuse across from my right angle, which is my one side. It obviously has been multiplied by 5, because it's no longer equal to 1, it's equal to 5. And so again, all of my side lengths I know are going to be multiplied by 5. Okay, nice thing about a 45, 45, 90 is that because these two angles are equal, their two sides are also going to be equal, both at either root 2 over 2 or 1 over root 2, whichever one you prefer. However, again, both of those sides have been multiplied by 5. Okay? And so if we multiplied it by 5, we'd get 5 root 2 over 2. Or if you do prefer the 1 over root 2, if I multiplied that one by 5, I'd get 5 over root 2. Both are acceptable. This one just has an unrationalized denominator. This one has an unrationalized numerator. Okay, and then last but not least, we did kind of look at utilizing these trigs in different ways, and so that's what this last page is going to do. And so we drew in that 45, 45, 90, and 30, 60, 90 triangles again, so that you had them to reference. You didn't have to keep turning the page. And we have, to start us off, 6 problems here just to kind of quiz ourselves on our angles. Try to not use your triangles. My recommendation is to maybe cover them up with a paper and see if you can just, again, kind of quiz yourself on your relationships here. So I'm going to do 1, and then I would encourage either after listening to 1 or 2 if you need to, but at some point pause the video, try some of these on your own, right? Are you actually understanding the ratios? Are you actually remembering what angles are associated with which measurement? Okay? Taking a look at number 11 here. Number 11, we have the cosine of theta equals root 2 over 2. And so the question is, well, which of my angles, which of my triangles, which of my angles, if I did an adjacent over hypotenuse, because again, that's what cosine is. Let me do that. Cosine is adjacent over hypotenuse, right? Ca. Which one of those angles, adjacent over hypotenuse, would give me a measure of root 2 over 2? And so if you remember it, great, you already know the answer. If you don't, you're having to kind of guess and check to a certain extent. And so root 2 over 2, maybe you go, oh, I recognize that's from the 45, 45, 90 triangle. Maybe I try 45 degrees. And I ask myself, okay, well, would the cosine of 45 degrees give me that value? Okay, well, if I did adjacent over hypotenuse for this 45 degree angle, and it doesn't matter which one, right? They're equal. So, but if I did adjacent over hypotenuse, my adjacent would be root 2 over 2 over my hypotenuse, which is 1. And the question is, well, is that equivalent to root 2 over 2? And it is. Dividing by 1 doesn't do anything. And so my angle is 45 degrees. Okay. Number 12, we have sine. Well, sine is opposite over hypotenuse, right? So the question is, well, which angle opposite over hypotenuse would have 1 over root 2? And again, at some point you might need to do a guess and check. Maybe you're looking at that going, I recognize that's from the 45, 45, 90 triangle. And so maybe you try that. And so pick one of your 45, 45 angles. And so if I picked this one, my opposite would be 1 over root 2 over my hypotenuse, which is 1. And the question is, well, is that equivalent? And again, it is. Remember, dividing by 1 doesn't do anything. And so my angle is 45 degrees. Okay? Again, remember, at some point, make sure you're pausing the video, trying some of these on your own. Number 13, we have tangent. Well, tangent, TOA, opposite over adjacent. And again, you're trying something, so maybe you recognize, oh, that 1 over root 3, I remember that one was from our 30, 60, 90 triangle, and maybe it's just that you recognize root 3 is here, and so you try one of them. And again, maybe you pick the wrong one first, but you try one. So say we tried 30 degrees. Well, for this 30 degrees, its opposite would be 1/2 divided by its adjacent, which is root 3 over 2. And the question is, well, are these equivalent? Remember, dividing by a fraction is the same thing as what? It's the same thing as multiplying by its reciprocal. So we're going to do 1/2 times 2 over root 3. Well, the 2's would cancel, and I'd be left with 1 over root 3, which is equivalent. And so my angle is 30 degrees. If you had picked the 60-degree angle first, so you didn't get 1 over root 3, well, then pick 30 and see if that works. Okay. Number 4, cotangent. Cotangent, you either know, so Cho-Sha Cow, you know it's adjacent over hypotenuse, adjacent over opposite. Or you know that cotangent is the reciprocal of tangent. Well, then if tangent is opposite over adjacent, cotangent would be adjacent over opposite. And again, the same question, which one of these triangles would give me a cotangent, or which of these angles would give me a cotangent equal to 1? And maybe you already know, maybe you could figure it out. Maybe at some point you're like, I don't know. So you start somewhere. You pick an angle to try. However, if you take a moment and think about it, I'm going to be dividing two numbers, and I need them to give me an answer of 1. What does that mean about those two numbers? Okay, well, the only way to divide two numbers and get an answer of 1 is if those two numbers are equal. And so that could be, if you can catch that, that could be a good place to start. So you'd be going, okay, well, first of all, which triangle even has two values that are equal? Well, 45, 45, 90 does. And so maybe I start there. And so pick a 45-degree angle, adjacent over opposite. Adjacent would be root 2 over 2, divided by my opposite, which also is root 2 over 2, right? Adjacent over opposite. And if I divided that, would that equal 1? And yes, it would. And so my angle is 45 degrees. Again, one more time, make sure you're pausing the video at some point, giving it a shot on your own. Okay, next up we have 15, cosecant. Okay, either you know what cosecant is, hypotenuse over opposite, or you know cosecant is the inverse of sine. Well, sine is opposite over hypotenuse. Cosecant then would be hypotenuse over opposite. Right, reciprocal. And you're looking for, well, who gives me a cosecant of root 2? And again, one more time, at some point you have to start somewhere. Maybe you're looking at this going, okay, root 2, well, I know the 45, 45, 90 has root 2's in it. Maybe I'll start with 45 degrees and see if that gives me an answer. Okay, well, hypotenuse for this 45 degree would be 1 over its opposite, which would be root 2 over 2, or 1 over root 2, whichever one you prefer. Okay, well, is that equivalent? So remember, dividing by a fraction is the same thing as multiplying by its reciprocal. And 1 times root 2 divided by 1 is root 2. And so my angle is 45 degrees. Okay, last but not least, we have our secant theta. So secant, hypotenuse over adjacent, or reciprocal of cosine. Cosine is adjacent over hypotenuse, so reciprocal. Again, at some point you have to start somewhere. Now this one, you might be flying a little bit blind initially because both of these triangles have 2's in it, if you look at them. And so maybe you just, again, you pick one to start. And maybe you work your way through, eventually landing on like, well, maybe it's the secant of 60. Let's try that. 60 degrees is right here. Its hypotenuse is 1. Adjacent is 1/2. Dividing by a fraction is the same thing as multiplying by its reciprocal. And 1 times 2 divided by 1 is 2. And so 60 degrees is my answer there. Okay, and then our last several here are going to be kind of trigs within context, I guess I would maybe put it that way. So 17, 18, 9, and 10. Okay, so with these last four, my recommendation in class was to have, or I shouldn't say recommendation, what we did in class was have people pause and, like with number 17, talk to their partner, see what they remember from last year, see what kind of things they can trigger for each other just through conversation. And so obviously if you're at home looking at this lesson, you won't really be able to talk to anyone unless you happen to be doing this video with someone. But I would still recommend pausing the video on each of these, seeing what you can remember. Label things in your diagram based off of information given. Take a look through the notes, see if there's anything that kind of looks somewhat like the values you've got. Like I said, try to get as far through the problem on your own as possible, and then start the video kind of when you are either stuck or have an answer that you want to check. Okay, so we're going to do 17, 18, 9, and 10. Like I said, my recommendation, pause the video before each one and try it on your own initially. Okay, number 17, we have a triangle here, isosceles triangle ABC. We're asked to find sine, secant, and tangent of A over here. However, to do sine, secant, and tangent, we do have to have a right triangle, and this given triangle is not right. However, if I drop an altitude here, now I've got a right triangle. This side over here, we've cut the base in half, so this side over here would be 8. And so then the question is, well, what's this side? You can either use Pythagorean Theorem, or if you recognize that this is a 3, 4, 5 triangle, they've just been multiplied by 2, then you already know your side length. So 5 times 2, 4 times 2, and 3 times 2, which is 6. And then we've got what we need for our trigs. Sine of A Opposite over hypotenuse would be 6 over 10, or 3/5. Secant of A, hypotenuse over adjacent, so 10 over 8, or 5/4. And tangent A, opposite over adjacent, 6 over 8, or 3/4. Okay, same thing, pause the video, restart it when you're ready with number 18. Okay, tangent of B. So tangent is opposite over adjacent. In this case, my opposite over my adjacent here is 12 over 5. Opposite over adjacent is 12 over 5. And so then the question is, well, what is its missing side? This is a 5, 12, 13 triangle. And with that, we have everything we need for the cosecant A, cosine A, and cotangent A. Okay? Cosecant, hypotenuse over opposite. So hypotenuse 13 over opposite 12. Cosine, adjacent over hypotenuse, adjacent 5 over hypotenuse 13. Oh, I apologize. I just realized I was doing it for B. Let me back up. Correct words, wrong numbers. So starting over, sorry, cosecant A here. Cosecant, hypotenuse over opposite, so hypotenuse 13 over opposite, which is 5. Cosine, adjacent over hypotenuse, adjacent 12 over hypotenuse 13. And then cotangent, adjacent over opposite, adjacent 12 over opposite 5. Okay, last but not least, we have numbers 9 and 10 up at the top. Okay, numbers 9 and 10 just give us one more chance to first look at a 30, 60, 90, and then at a Pythagorean triple, and to remind ourselves of the fact that cosine and sine are directly linked to your x, y coordinate. Okay, so again, go ahead and pause the video, try 9 on your own, restart it when you're ready. Same thing with 10. Okay, so 30, 60, 90. And we have our hypotenuse of 1. Across from the 30 is my 1/2. Across from the 60 is my root 3 over 2. And so for your xy here, your x coordinate, how far sideways did we go? We went root 3 over 2 sideways. And how far up and down did we go? In this case, we went up 1/2 for my y coordinate. And we'll learn in review in a later lesson that this x-y coordinate is directly linked to your cosine sine alphabetical order. Okay, then number 10. Okay, number 10, we have a 5, 12, 13 triangle. My x coordinate, how far sideways did I go? That is 5/13 sideways. The question is now, well, how far up and down did I go? If you are not comfortable with the fact that this is a 5, 12, 13 triangle, you could do your a squared plus your unknown squared over here, so b squared equals your c squared. And you could solve for b, you'll get, oops, that should be squared, sorry. You could solve for b, you'll get 12 over 13. Or if you can recognize that this is a 5, 12, 13 triangle, just that every side has been divided by 13, you can speed up the process a little bit. Because this 13 here has been divided by 13, giving me 1. The 5 has been divided by 13, 5/13. And so then the 12 would have had to have been divided by 13. And so this missing coordinate over here is a 12/13. And again, in a later review, we will be looking at the fact that this xy coordinate is directly linked to cosine and sine alphabetical order.